Good morning and welcome to College Algebra here at HCU. If this is your first video, I just want to talk about a few classroom things. As this online class, there's going to be a lot of do it at your own pace or take hold of your own learning. And I want to look at a couple resources that we have for you set up, and then we'll get right into section 2.2. So the first thing I want to point out is that your textbook, which you have links to online, it is really, really important as you go through and try these try-it problems and the homework practice problems before our first test that you read through the sections. You'll notice in each section there's equations, there's definitions, and there's examples. The examples will teach you how to do it, like this one right here. And then they'll have some try-its. That's what we're going to be mostly doing in class and on these videos, is going through a few of the try-it problems. And then at the end of the textbook, which isn't part of your homework and it isn't part of the assigned readings, but we've got section exercises that are a great resource to study and practice. Try the harder ones. Some of them have solutions built in that you can click a link to like that. And you can go and look and see if you got it right. So that is just one extra resource for you on top of the videos, the blank notes, and the completed notes in class. So without further ado, I'm glad you're here. I'm glad you're watching. And let's jump right into section 2.2, which is linear equations and rational equations. All right. So, linear equations and rational equations is a short section that's kind of a preliminary knowledge and the things you need to know for this class. There's going to be later sections on linear functions and rational functions, but this is just a groundwork of all of the algebra and the small arithmetic that you really have to know before getting into this class. So if you find today particularly challenging, it's worth practicing and re-practicing as you and coming back to and visiting this section as these skills are needed for the entire class and all of math in the future. So we're going to get started with a few selected try-it problems and then we'll wrap up for the day. So the first thing that I want to look at, we're going to look at this equation really fast. It should look familiar. There's another one that's really similar. You've probably seen this y equals mx plus b, if you remember that back from math classes in the past. This is just the general form of the linear equation, which is a slope, a variable, and a constant. So we've got ourselves a slope, a variable, and a constant, and we're not worried about those definitions right now. All we're going to talk about is how do you solve these things. I'm going to skip a couple of these easier first ones and let you try them on your own. And we're going to jump into this one that really uses all of the tools of the math toolkit. This is going to use distribution. This is combining like terms. Maybe you've heard this don't call me after midnight acronym that we've used in math classes in the past, where you distribute, you combine like terms, you move the x's to one side, you add or subtract the constants. I know we're going fast, but if you need an explanation of this, there's tons of YouTube videos already linked that you can go and look through and they'll talk you through how to do this. And then you multiply or divide that last term. So let's see how this plays out. And we'll use this DCMAM acronym to help us through this. So the first step, it says distribute. So we're going to take some of those original constants outside of the parentheses and distribute them and see what we end up with. So we end up with 8x, because 4 times 2x is 8x, plus 4 equals 29. Leave everything else alone. And we've got 6x minus 15. I'm going to drop a line through my equal sign so that I can keep my equations correct on both sides and see, okay, we've distributed. There's no more parentheses. There's nothing else to distribute. Now I'm going to combine like terms. So do I have any variables on this side? I do. Do I have any variables on this side? I do. But I don't see anything I can combine yet. I have some constants. No other constants there. Oh, there's 2 constants that we can combine. So I'm going to rewrite one more time and leave this all alone. And I'm only combining like terms on one side of the equal sign. So we've got 29 minus 15, which is going to be 4 and 1, so 14, plus 6x. So you'll see what we did there is we just combined those like terms on each side of the equal sign. Now we're going to move the x's over. We'll do this in 2 steps. If you get really good at algebra and you want to start skipping steps, that happens. But we're going to do it one step at a time. I think M is move the x's to one side. This says the left. It doesn't really matter. I'm not going to formulaically tell you what to do, but often I'll try to avoid negative signs. So I'm going to move the x's to the left side by subtracting, because 6x minus 6x is 0, and what you do to one side of that line, you have to do to the other. So now we're left with 2x plus 4 equals 14. And the next step is add or subtract constants to the other side. And so I'm going to get rid of this 4 by subtracting it on both sides. It's going to go away because 4 minus 4 is 0. And we are left with 2x equals 10. And last but not least is get that constant out of there. So we're going to do one more divide by 2. What you do to one side, you have to do the other side. Careful here, you're not going to get rid of that x because 2x divided by 2 leaves the x alone, and the 2 over 2 turns into 1. You've got 2 x's over 2. You've got 2 parts over 2 parts. So we're going to be left with just x equals 5. Zoom out for a second, let you look at that. And that's applying the DCMAM acrostic poem or acrostic acronym to this first equation. All right, let's hop down and do something a little more challenging. So that's a linear equation. That's a really complex linear equation with a lot of moving parts. We move down to rational equations. Now, like I said, we're going to have a whole nother section on rational functions and linear functions that's going to teach a little bit more about applying these to graphs, inserting inputs and getting outputs out. But for now, we're just going to look at solving these equations. Just one variable solves 4 equations. So I'm going to skip these first ones, and again, I'm going to move down to a little harder one for the sake of time. You can try these on your own. The solutions are posted. These are just try it problems for you to practice at home on your own. So let's look at this thing. I got a long equation with a lot of moving parts. We've got 3 different denominators, which are more related than they seem, and we've got some constants in our numerators. The first thing I like to do when I see something like this, I see something on the bottom, and I think back to 3rd grade when my teacher told us there's only one bad thing in math that you can't ever do. There's a lot of bad things, but for now, there's one bad thing in math that you really can't do, and that was divide by 0, right? And so dividing by 0, any number divided by 0, that's super bad. Don't do it ever, right? Okay, so we can't divide by 0, which means I got to make a note or a domain restriction. So I'm going to make a domain restriction, but for now it can just be a side note because we haven't discussed domains yet in this class. So the domain restriction is I'm looking at the bottoms, I'm saying what value of x would give me a 0 on the bottom. And if I look on this far left side and I say, what x could I put in there to give me a 0? Or if you want to be more specific and go x minus 2 better not be 0, right? And then you could drop your line again, add 2, and you see, oh, x better not be, or x does not equal 2, because that would be really bad. So off to the side near this domain restriction, I'm going to do that, and I'm going to say x is not ever equal to 2. That would be bad. There's another number in there. If you look at that second term, we're going to see that x also better not be -1. And then if you see something interesting that goes with quadratic equations, and maybe you've heard of FOIL or the box method or things like that, you might notice that these 3 are more related than they seem. If you were to factor out the far right term, or if you were to FOIL the first terms, you might see something cool happen, that x times x is technically x squared. We've got ourselves a -2x. We've got ourselves a positive 1x, and we've got ourselves a -2. And if you combine those like terms, you're going to end up with that equation on the right. So our denominators are actually the same if we were to multiply them. That's going to be helpful later. So we've got ourselves a domain restriction. We've made a little note about the denominators and how they're, if we were to multiply the 2 on the left, we'd probably end up with the one on the right, which is a pretty common pattern. And now we're going to see, okay, well, how do we solve this? How do we get those x's by themselves? So here's what we're going to do. We're going to take all of the bottoms, and we're going to find the lowest or least common denominator. We're going to see what denominator includes all of the denominators and would cancel it out. And because we just saw that if we multiplied the left 2 denominators, we'd get the right one, that's probably what we're going to end up using as our lowest common denominator, because all of the 2 factors on the left turn into the right. So let's see what, so if we make a note and we say our LCD, it's technically just that term on the right, which I'm going to write in a real fancy way by multiplying the 2 on the left. And then what can we do with that LCD that's going to help us get those x's out of the bottom, even though we've made a note that says our domain's got to be restricted? We're probably just we can just multiply all the way across the equation. We're going to multiply both sides like we've been doing by that LCD and see what happens. Some cool stuff is going to start happening. So on the left side, we've got the whole equation, which is going to take a while to write. And on the right side, we've got, putting it in brackets, the whole equation. And what I'm going to do is I'm going to multiply both sides, not the whole equation, because we're not multiplying across an equal sign, but we're going to multiply both sides by this LCD that we just decided included. Boop. And now what we see is if we start distributing and we start eliminating terms, we're going to come up with a much simpler equation. And so just like before, we're going to distribute first, distribute, and we're going to end up with 2 times that whole LCD plus 1 times that whole thing, because distribution you have to do it twice, right? Over, oh, there's a cancel, over, there's another cancel, and then we're just going to put the whole thing on top. And what's really cool about this side is we just decided that these 2 terms, the multiplication and that long quadratic, are exactly the same. That whole side's going to turn into a 1. So we've got some more work to do. We're going to do a little canceling, keeping in mind our domain restriction, a little canceling, keeping in mind our domain restriction, and a lot of canceling here, where that's not going to turn into 0 because we're not subtracting, but it's going to turn into a 1 equals 2 times x plus 1 plus, and this side just turns into x minus 2. And now we've got an equation of the same form that we just solved a second ago. So we're going to end up distributing, get ourselves 2x plus 2 plus x minus 2 equals 1. Combining like terms, 3x, ooh, that 2 and that 2 are going to combine and turn into something pretty neat. 2 minus 2 is 0. And now if we do our last step, which is dividing, we are going to find that x equals 1/3. And I'm going to check that with my domain restriction to make sure I didn't get a bad number or a restricted number for x. So the 2 numbers that x was not allowed to be were 2 and -1. That solve, or that solution, is not one of those numbers, so it is a perfectly fine solution for this rational equation. All right, we're going to move to, that was probably the hardest type of problem on this section. Maybe practice it, go find, I think the one right next to it is going to have a similar thing where you're going to have to find a common denominator to multiply across. Probably your lowest common denominator is going to always be multiplying the 2 denominators. If you read through the text, it'll talk to you about some shortcuts to find it. But if you want your lowest common denominator here, it's probably going to be multiplying those 2 and then multiplying that across both sides and seeing what happens as you cancel some stuff. So that's just a little hint if you were wanting to practice that tough problem on your own. All right, let's keep rolling. We're going to talk real briefly about the slope of a line. We'll also hit it in linear functions, but it's really important to have a groundwork for this. You've heard of slope or rate of change or change in y over change in x, or y2 minus y1 equals x2 minus x1. There's so many, you might have heard of delta y over delta x. There's so many ways that slope is represented in the math and physics world. We're just going to introduce it real briefly here and say, hey, whatever the change in y is, we're going to divide it by the change in x, and we're going to realize a slope. So for this, I'm going to label a couple, y1, x1. So that's my first term. This is technically my 1 term or my first term. 2, we're going to go x2, y2, and then we're just going to plug and chug that into our equation and see what we get for our m. So m is going to be 4 minus 6 over 1 minus, careful with this negative sign, I'm going to throw some brackets or parentheses around it so I can be careful with it. End up with -2 over 1 minus -2. If you've ever seen this big plus sign that sometimes people make, it's going to end up with 3. And so our slope is -2 over 3, or it changes, it goes down 2 and to the right 3. If you remember that from graphing linear functions, it's a change in 2 over a change in 3, or an x change in 2 over a y change in 3 in the negative direction. Cool. So there's a quick and dirty slope calculation. There's some things that fall out of slope, like perpendicular and parallel lines, and undefined and horizontal lines that we will talk about real briefly, and then we'll be done. So I have this highlighted here. This acronym, HOI-VUX, doesn't mean anything. I don't know that it's particularly words, but it's the way that I've always remembered it. Your HOI stands for your horizontal, your zero slope, that's not how you spell slope, your zero slope, or your y equals form. Which means your VUX is probably all the opposite things, right? You've got your vertical line, you've got your undefined slope, and you've got your x equals 4. And so that's a good way to remember, because I see a real common mistake is just to forget what format these lines are in, these horizontal or vertical lines. And this is a real good way, hoy bucks. If you can remember that, you'll always have horizontal, y, vertical, x, hoy bucks. And so here we go. I'm going to take 2 points. And instead of calculating the slope like we did last time, though you could do that and find it, I'm just going to plot these points and see what happens. So if you remember -5, 2, you go over 5, and you go up 2. So that's that point right there. -5, 2. I'm going to call that A for now. Change colors and call this one B. 2, 2, over 2, up 2. And if we were to connect those dots with a straight line, we would probably see that's a hoy line or a horizontal line, right? Which means we've got our slope is 0, our change in y over change in x is 0, and we've got y equals 4. Well, go look at the 2 points. You can ask yourself that question. What does y equal? In both of those points, y equals 2, and that's the form of the line. So we've got ourselves linear equations to solving for x. We've got ourselves rational equations where you got to find that least common denominator, multiply the tops by it, and see if you can find a way to eliminate them off the bottom, and solve the tops just like we did in the first step, keeping in mind those domain restrictions or those errors that you would get if x were to be any term. And last but not least for this section, section 2.2, we've got this definition of parallel and perpendicular lines. It really does boil down to 2 things: same slope and negative or opposite reciprocal slope. Sometimes I'll teach it and I'll call it flip. I mean, you have to remember what that stands for, but if you can remember, you got to do 2 flips. You flip the fraction and you flip the sign, S-I-G-N. You flip it, whether it's positive turns to negative, negative turns to positive. And so if you can remember flip, that's your perpendicular line. Same slope, that's your parallel line. So let's hop down and do one more problem, even though I didn't highlight it. We're going to find an equation, because this is going to be practice finding. This kind of sums up the whole chapter. Finding an equation, finding a parallel line, identifying slope, all of those things. So find an equation parallel to this line right here. First off, the line's not in a great form to see slope, though it's pretty close. First thing I'm going to do is get y by itself. If you remember that from a long time ago, everyone's always saying get y by itself to find a function. So y equals, I'm just going to move that 7 over. You're going to see it happen. It looks like that, with that line dropped right there. What you do to one side, you have to do to the other. We're going to end up with y equals 5x minus 7. Okay, well now I've got a slope. Boop. I've got a slope right in that m section, or the a constant from earlier. So I've got myself a slope for that line. Cool. But now they're asking for something different. They're saying passing through a point. So I've got a slope and I've got a point, and I need to figure out how to find an equation with a slope and a point. If we scroll up a little bit, or you look at your textbook, somewhere along the way, they're going to give us this nice, neat point-slope formula, which is just an equation given a point and a slope. Notice one of these has a little subscript 1 right there, and one doesn't. That's the one we're plugging it into. We're plugging it into x1, y1 to see what happens. And then that m value right there, that's our slope. This is all in the textbook. If you did your reading and this all makes sense to you, that's great. If this is all new to you, really read through that textbook. Talk to your instructor, practice the homework modules on practice mode, practice some of these exercises at the end of the textbook, because this is really crucial for the rest of this class, is all of this plugging and chugging and figuring out how equations apply. So here we go. That formula from earlier was y minus y1 equals m slope x minus x1. And I'm just going to take all these things that we just learned and plug them in, right? So I've got a point, so I'm going to go y minus, and I've got that -2 right there. I shouldn't have done that. Got y1, and I've got x1. Y minus -2. I'm going to simplify that later, and the final step to make it real pretty. M, I'm going to leave alone because we haven't talked about slope in this problem yet. And x minus, I'm going to simplify that too later. So let's go ahead and simplify it now, and then we'll plug that slope in. Minus a negative, that's a plus, so we're stuck with y plus 2 equals m, leave it alone, x minus -1, x plus 1. Cool. We got ourselves a formula. We just need slope. Well, we've got this nice word parallel, which we just said means same slope. And so we've got our slope then. It's the exact same slope as the line before. That's our slope right there, that 5. So I'm going to hop down here. I'm going to take that 5 and plug it right in for m, which is the variable that stands for slope. And so now I've got an equation for a line. I've answered the question. This is point slope form. But just to be good mathematicians and to do a little bit more than they asked, which is always a good thing to do, let's get it in y equals form and see what happens. Let's apply that DCMAM where we distribute and combine like terms to get y by itself and see how what it ends up looking like. So first things first, we're going to distribute, like we said earlier. Y plus 2 equals, distribute the 5, distribute to both the x and the 1, and we've got 5x plus 5. That looks like that. I'm not going to leave it there, but distributing that with a multiplication from the 5 to the x and the 1. And now we'll get y by itself by subtracting 2. Minus 2, minus 2. Only subtract it from the like term. Only subtract it from the same variable, same coefficient. Y equals 5x plus 3. We've got ourselves a new formula. Same exact line, new formula for the line, and this one is in slope intercept form. Zoom out for a second. Awesome. Well, that is section 2.2. That is linear equations and rational equations and how to solve for them. I would highly, highly encourage you to read through your textbook and do some practice exercises. Read through the try-its on this page. Practice a few of them on your own before attempting the homework, and then go into the homework having a firm grasp on these linear and rational equations and how to solve them so that you can do the best that you can in this class and in all the sections to come. Don't forget about that textbook online and to read it on OpenStax. College Algebra 2E is a great place to find it. I know the link will be in your Blackboard class. Don't forget about your homework. And don't forget to contact your instructor with any questions you have via email or Blackboard. Thank you for watching. I hope you have a great rest of this class, and I'll see you here for section 2.4.